thanks for your patience. So the goal today is to figure out what something like this means. Okay, we know how to deal with this now, right? That's going to be 2 times 2 times 2, which is 8. We know how to deal with this, right? That we now know can be written as a radical. So that's the square root of 25, which is 5. Our goal today is to figure out, what does this mean? What if we have a negative exponent? How do we deal with that? Okay, and then we'll also look at negative fractional exponents, because if we know how to deal with negative exponents and we know how to deal with fractional exponents, we can put the two together, and we may do something like this. Negative 1/2, or sorry, we might do something like that too. Okay, so that's the goal. Now to start, we are going to do a little bit of an investigation here. So I want to evaluate all of these powers. You should be able to do the first 5. Okay, so if you look at 2 to the 4, what's the value of 2 to the 4? 16. And how do you get the 16? You multiply 2 together 4 times, right? So 2 times 2 times 2 times 2. I think I said that 5 times, but 4 of them is 16. Okay, what about 2 cubed? 8. 2 squared? 4. 2 to the 1? 2. 2 to the 0? It's 1. Yes. So any base raised to the exponent of 0 is equal to 1, as long as the base itself is not 0. Okay? 0 to the 0 has no meaning. That if you take calculus in a couple years, then we'll talk about why. Okay? But any non-zero base raised to the exponent of 0 has a value of 1. And in fact, this is a definition. Okay, so that means mathematicians have decided that this is the way that we are going to evaluate the exponent of 0. But it fits really nicely, A, with the pattern that's going on here. We're going to talk about that in a minute. And B, with all of the other exponent laws, which we'll look at in more depth tomorrow. Okay, so I'm going to revisit why tomorrow. But let's just talk for today about what's going on. What's the pattern on the left? Yeah?
With every lower exponent by 1, the answer is, wait, 1.
So I just want the left side. What's the pattern? How would you know to draw the next? How would you know what to put in the next line of the pattern?
Each exponent increases by 1.
Yeah, we keep going down by 1, down by 1, down by 1, right? So over here, we'll do this in a different color actually. -1, -1, -1, -1, -1. Okay, so that's the pattern on the left. What's the pattern on the right? Yes. Divide by 2, divide by 2. Okay, so if we're trying to figure out, well, what would this one be? 2 to the 0. It should follow the same pattern on the right, which is that we take the previous one, we divide it by 2. And 2 divided by 2 is 1. Okay, now this continues. You haven't seen any exponent below 0 yet, unless, well, no. Yes, below 0. I was going to say below 1, but actually you have seen, yesterday you saw exponents that are below 1, like 1/2. If we continue this, -1, -1, -1. Okay, what do you think is going to happen to these values on the right? What do you think the next one's going to be? Yep.
The next one is
0.5. 0.5, that's true, that's the value. Can you write that as a fraction? 1/2, yeah. So this guy is 1/2. This just does not want to agree with me today. And this one, 2 to the negative 2, what would you have to do? Yeah? Say that again? It's 1 over 4. Yes, because you take this 1/2, we're going to divide that by 2, and this one is 1/4. Okay? 2 to the negative 3, 1 over 8, and 2 to the negative 4, 1 over 16. Okay, so we keep dividing by 2, divide by 2, divide by 2, divide by 2. Now, these are the values of these powers with negative exponents, but I'm actually going to rewrite them in a different way so that we can make a generalization here, right? So if we look at 2 to the negative 1, 2 to the negative 2, 2 to the negative 3, 2 to the negative 4. Okay, this one has a value of 1 over 2. If I want to write that where there's an exponent on the 2, that would be 1 over 2 to the 1. Okay, this guy was 1 over 4. How would you write 4 as a power with a base of 2? Yeah. Yeah, so this is actually 1 over 2 squared. Okay, 2 to the negative 3 was 1 over 8. How do you write 8? Using the base of 2. Yeah.
1 over 2 cubed.
1 over 2 cubed. And then finally, this is 1 over 16, which is 1 over 2 to the 4. Okay, and in general, this is how we make meaning of negative exponents. So if you have a to the negative b, that is equal to 1 over a to the positive b. Okay, so what are we going to do? Well, if you think of this as a fraction, we are going to move this down to the denominator and make the exponent positive. Okay, and we're going to do lots of practice that you get a handle on how we deal with all of this. Okay, so if we take a look at some of these, okay, we're going to do some of these really fast, hopefully, and then maybe some of the fractional ones we'll need to spend a bit more time, but that's okay. And then we're going to look at how do we compare to the ones on the right.
Excuse this interruption. Ms. McKenzie, can you call the main office, please? Ms. McKenzie.
Okay, 4 to the 1, what's the value? 4. 5 to the 1, 5. 6 to the 1, 4 squared, 5 squared. Oh, wow, what happened there? Hold on a sec. This thing has a mind of its own. Okay, so this is 16, 5 squared, 25, 6 squared, 36. What about 4 to the 1/2? 2, good. So you guys can do that in your head. It's the same as the square root of 4, so that's 2. 16 to the 1/2, 4. 27 to the 1/3, 3. Okay, what about 4 to the 3 over 2? Yeah, someone said it. But if you can't do that one right away in your head, right, because the numerator here is not 1, just convert it into radical form, right? So if we draw a radical here, the radicand would be 4. The index is 2 because that's the denominator. And then we cube it. Okay, so the square root of 4 is 2. But then we have to cube it. So that's 8. Okay, what about 16 to the 3 over 2? Good. It's 64, yeah. Because here we're doing the same thing as a radical. Radicand is 16, the index is 2, and this is cubed. Okay, so the square root of 16 is 4, but then we have to cube it, and that's 64. Okay, and what about 27 to the 2/3? Good, that's 9, awesome. And if you couldn't see that, we're looking at the cube root of 27 squared, right? Cube root of 27 is 3 squared, which is 9. Okay, so these are all of the positive exponents, and we're looking at whole numbers, and we're also looking at fractional exponents. Okay, now, the negative counterpart. All right, so this guy is going to be 1 over 4 to the 1, which is just 1 over 4. Okay, this one is 1 over 5 to the 1, which is 1/5. This one's 1 over 6 to the 1, which is 1/6. Okay, what do you think about this one? Yep.
1 over 16 to the 1?
Well, it's 1 over 4 squared, because we want to know it is 1 over 16 to the 1, but as a generalization, how do we deal with something like this? How do we evaluate it? Right? A to the negative b is 1 over a to the b. Okay, so we are going to put this into the denominator, and now it has a positive exponent. So it's 1 over 16. And I know that many of you will be like, okay, well, I can see that basically these ones are the reciprocal of the ones on the left. Do you guys know what that means, reciprocal? Yeah, it's when you, does anyone not know what it means? Okay, I'm going to say anyway, just in case some people don't remember. It's essentially when you flip the numerator and denominator, right? So if that one is 4 and this one is 1/4, well, 4 as a fraction is actually 4 over 1. So if I flip the numerator and denominator, these are reciprocals. Okay, so if you evaluate it with a positive exponent, you can just take the reciprocal. That's one approach. Another approach is make the exponent positive, like we did here, and then evaluate it. Since we've already evaluated all the positive ones, it may just be easier to take the reciprocal approach. But sometimes we may not have evaluated the positive ones yet. Okay, this one is going to be 1 over 5 squared, which is 1 over 25. Okay, 1 over 6 squared, 1 over 36. Okay, well now if you have a negative exponent that's also fractional, you just do the same thing, right? It's going to be 1 over 4 to the positive 1/2. Okay, and that is 1 over 2, because 4 to the 1/2 is 2. Yes? So if you wanted to make it a radical first, yes, you can. So, and we're going to talk more about this in a couple of minutes. When you're evaluating a power that has a negative fractional exponent, you have to deal with two things: the fact that it's fractional and the fact that it's negative. And you can actually do those in either order. Okay? So the way that I just did it was I dealt with the fact that it was negative first, and then I evaluated the fractional exponent. But you can actually do it in the opposite order as well. So I can show you what that looks like. Oh, wait, that's not. If you are dealing with both, I'll do it over here, right? If you say have 4 to the negative 1/2, okay? One approach is to do what I just did, which is say, okay, well, that's equal to 1 over 4 to the 1/2, which is 1 over the square root of 4, which is 1 over 2. Okay, so here what I did, I made it positive, I converted to radical form, I evaluated. You can do it in the opposite order there, though, where you have 4 to the negative 1/2. The important thing to know, though, is that you cannot have a negative index. So this negative sign must go with the exponent, not with the index, okay? So this is going to be the square root of 4 to the negative 1. The square root of 4 is 2. So that's 2 to the negative 1, which is 1 over 2 to the 1, or 1 over 2. Okay, so you can do it in either order. Yes, it's a good question. All right, 16 to the 1/2, or negative 1/2 rather, is, we're kind of noticing that this is getting repetitive here, so this is 1/4, right? This is going to be 1/27 to the 1/3, which is 1/3. Okay, this will be 1/4 to the 3/2. I need to put more space in here, which 4 to the 3/2 was 8, so this is 1/8. Okay, and then we'll just keep going. 1/16 to the 3/2, which is 1/64, and this is 1/27 to the 2/3, which is 1/9. Okay? Actually, before we do that, I want to just make some generalizations. So we already did make a generalization, which was this. A to the negative b is 1/a to the b. Okay, so generally, a to the negative b is 1/a to the b. What do you think this would be? What if the negative exponent is in the denominator? Yeah.
Wouldn't it go to the top?
Yes. So now it's going to move to the numerator. Okay. So this is going to be just a to the b. Okay. Why is that? Okay. Why? Well, if we follow the same rule as above, 1/a to the negative b is 1/1/a to the b, because that's equal to that. Okay? Now, this numerator, I'm actually going to write it as a fraction as well. 1 as a fraction is just 1/1. Okay, now why did I do that? Because what we're doing here is division of two fractions. So we're going to talk more about this towards the end of class because I want to go through that pre-assessment. But essentially when you take one fraction, divide by another, you have to take the first one and multiply by the reciprocal of the second one. So that the reciprocal of this is a to the b over 1. And that's essentially just a to the b, right? Because we have 1 times a to the b is a to the b, over 1 times 1 is 1, which is just a to the b. Okay, so that's actually sort of the mechanics of what's going on there. Yeah?
What about imaginary numbers?
Imaginary numbers? So imaginary numbers would only happen if the base is negative and the exponent is fractional and the denominator is even. Okay? We're not, in these scenarios, going to be dealing with any negative bases. Okay? So you don't need to worry about that. The bases will always be positive. Okay? All right. Now, the last one I want to talk about is something like this. Okay, what if the base is a fraction and your exponent is negative? Anyone want to take a guess at what that's going to be? Yep.
Does it apply to the whole?
Mm-hmm. Applies to the whole fraction.
So therefore you'll flip it?
So yeah, so this is actually going to be b over a to the positive c. It's the reciprocal. So take the reciprocal of the base, and then the exponent becomes positive. Now, why does this happen? again, it's going to go back to our exponent laws and what we've already learned about negative exponents. So if you expand this, the couple steps that are missing in between is this. This is a over b to the negative c. Now, if a base doesn't have an exponent written in, what is the exponent on that base? It's 1, right? Okay. Well, this negative c applies to both the numerator and to the denominator. So if we want to remove the brackets, we have to distribute this in. It applies there, and it applies there. So this is going to be a to the negative c over b to the negative c. Okay, so now we have two negative exponents. Well, if you have a negative exponent in the numerator, you got to move the whole thing down, make it positive. If you have one in the denominator, you move it up and make it positive. So this is going to come down. This is going to come up. This is going to be b to the positive c over a to the positive c. And that can be written like this. Okay, so these are the two things that are happening when we go directly from here to here. This is a really common type of question, though. We see this type of thing a lot. So I won't expect you to show that process when you're simplifying. You can go directly from here to here. But I also don't just want to give you like rules that drop from the sky without explaining why. Okay? All right, so these are important things to remember. These are not, actually, I haven't given you guys formula sheets yet. I have them printed. I'll give them to you today. This stuff, though, not on your formula sheet. You need to know that. Okay? And really, it just all comes from the first one. This is sort of the main rule. And these ones, in mathematics, these are called corollaries. Right? So this is the main theory. These are like appendixes that exist because of this one. Okay? All right. Let's try some questions. Okay, evaluate each power. I just want to see how many questions did I actually give you here. Oh, there, we're almost done. Okay, so evaluate each power. Okay, oh, I lied about the negative base thing, but I'll explain that in a minute. Okay, so 3 to the negative 2, how would you evaluate that? Yep. Right, 1 over 3 squared. So this is 1 over 3 squared, and that's 1 over 9. Okay. What about this one? Negative 3/4 to the negative 3. Yep. Yep.
Wouldn't the negative apply to both the numerator and the denominator?
Uh-huh.
Yeah.
Yep.
Do you switch the
Yeah.
numerator and denominator?
So when you have a base that's a fraction and the exponent's negative, you can make the exponent positive if you take the reciprocal of the base. So negative 4 over 3. Okay, now the value of this is essentially negative 4 over 3 times negative 4 over 3 times negative 4 over 3. Right, so negative 4 times negative 4 times negative 4 is negative 64 over 27. Okay, what about this one, 0.3 to the negative 4? Yeah.
You could change it to a fraction and then flip it.
Yeah, you could change it to a fraction and then flip it. So I've seen people do two things with this one. Some people do this. 1 over 0.3 to the 4. Okay, 0.3 to the 4 is, hold on, is it 0. I think I have one too many zeros in there. Can someone check? Do I? Do I have one too many? Yeah? Okay. The 81 is in the thousandths position. Okay. So it's 0.0081. Okay? Now there's nothing mathematically wrong about this, but it's kind of like bad grammar. The analogy that I would make is using bad grammar in an essay, because it's better grammar, better math grammar, if you will, if you have a rational number, to write both the numerator and the denominator as integers, if you can. Okay, so for example, instead of writing 0.5 over 2, you'd make it 1 over 4. It has the same value, but the second one is better math grammar. Okay, so you could start from here and deal with it that way, or you can use your suggestion.
I was just wondering, instead of using a decimal, could you just do 3 over 10?
Yes, and convert the base to a fraction first. And then take the reciprocal of the base. So this is going to be, 10 over 3 to the 4, which is 10 to the 4 over 3 to the 4, which is 10,000 over 81. Okay, now you can still get there in this case. The 81 is in the 10th, 100th, 10,000th position. That's the place value of the 1, and this is 1. So how do we make this an 81 instead? We multiply the numerator and the denominator by 10,000, and then you're going to end up with this fraction anyway, right? But I'm just showing you different methods and different approaches. Neither of them are wrong. This one, the second was probably a little cleaner than the first one. It's easier to get to that fraction, but it's not like you can't get there that way. Okay? All right, so I want you guys to take a few minutes to try these 3. And then we'll talk about negative exponents that are also fractional in a second. Okay? Two were really good. For C, there's a couple of challenges here, right? Obviously, one of them is the negative exponent, but then we have this base of negative 1.5, okay? And the easiest thing to do with decimal bases is to convert them to fractions first. So I saw a lot of good things going on in that step. A lot of things were correct. There's some places where people are struggling. So as a fraction, okay, I saw a lot of people say that this is 1 5/10. That's a really good starting place. Okay, is that reduced? No, how would you reduce it? Yeah, 1.5. Oh, I made a mistake. It's negative, right? Negative 1.5. Okay. If I raise that to the exponent negative 3, though, that's really not going to help me in this format. This is a mixed number, and I need it to be an improper fraction. How do I convert that to an improper fraction? Yeah? Or from this standpoint, negative 3 over 2, right? Do you guys want to review how to do that? No, you're okay? Okay. If you need to review that, I'm not going to do it with the whole group because I think most people have a handle on it. But if you don't know how to go from here to here, then come to a tutorial, okay? All right, so this is the fraction equivalent of negative 1.5, and it's reduced. So I'm going to start out by doing this. Okay? Now I can deal with making this positive. If I make that positive, what's going to happen to the base? Yep. Yeah, flip the numerator and denominator. Okay, and then some of you can do this in your head, but some of you guys may need to expand at this point. That's fine, right? So the final answer, is that going to be positive or negative? Negative, yeah, because there's 3 negatives multiplied together. So that's negative, and then 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. Okay. Another thing that I just want to clarify about negative fractions is that you have to have one negative sign, but it can go anywhere. And what I mean by anywhere is this. Okay, the negative sign can go in front, it can go in the numerator, or it can go in the denominator. These all have the same value. Okay? All right, so we're going to talk about how to deal with these, and we already did a little bit on the first page, when we have a negative fractional exponent. And then that'll pretty much be it for today. Okay? So evaluate each power without using a calculator. So we've got 8 to the negative 2/3. So in these types of questions, we have to deal with 2 things. One of them is the fact that the exponent is negative, and the other is that the exponent is fractional, right? And I mentioned this a couple minutes ago, but you can do that in either order. And I wouldn't say that one is better than the other. I would say out of habit, I tend to do one more than the other, but you can do it. It's not like one makes the process more simple, okay? Personally, I tend to deal with the fact that the exponent is negative first. Okay, so I would take this and I would write it as 1 over 8 to the 2/3. Okay, and then I deal with the fact that now the denominator has an exponent that is rational, right? So now I'm going to convert that into radical form. So that's going to become 1 over, here's my radical symbol, the 8 becomes the radicand. Okay, what's the index? 3, because the index, that's okay, the index becomes the denominator rather becomes the index, and then I'm going to square that. It's not negative 2 because I've already made it positive because now it's in the denominator. Okay? This is 1 over cube root of 8 is 2 squared, which is 1 over 4. Okay? Now, that was a good question, though. When would the 2 be negative? The 2 would be negative if you dealt with these two things in the reverse order. So if you dealt with the fact that you have a fractional exponent first, right? You can also do it this way. That's when the 2 would be negative. Okay, well, what is this? The cube root of 8 is 2 to the negative 2, which is 1 over 2 squared, which is 4. Or 1 over 2 squared, which is 1 over 4. Okay, so honestly, try it both ways, see which one you prefer, and then stick to it. Or you can alternate as well if you prefer. Okay, let's look at this one. 9 over 16 to the negative 3 over 2. What would you do first here? Yeah.
Would you reduce would you reduce 9 over 16?
If you can reduce the base, then yes. Can you reduce this base, though? No, this is already reduced. So if you can reduce, then for sure do it. Yeah.
Square root 9 over 16 and then leave the numerator negative 3
Okay, yep, so that's sort of the approach on the left that we did with the other one. So one thing that you could do is convert this to a radical first. So converted to a radical, it would be the square root of 9 over 16 to the negative 3. Okay, well, what's the square root of 9 over 16? 3 over 4, so that's going to become 3 over 4 to the negative 3. How do you solve it? Yes.
Make the fraction reciprocal and
Right.
the exponent positive.
Right, so write this as 4 over 3 cubed. And then that's 4 cubed over 3 cubed, which is 64 over 27. Okay, so that's one approach. That's dealing with the fact that it's fractional first. If you dealt with the fact that it's negative first, right, 9 over 16 to the negative 3 over 2, how would I make this positive? If I want this to be a positive exponent right now, yeah.
Would you make the exponent a reciprocal?
Okay, so I'm glad you brought that up because that's a super common error. A lot of people will flip this and say it's 9 over 16 to the 2/3, okay? The only time that you will write a reciprocal is of the base. You will never write a reciprocal of the exponent. The only thing that happens to the exponent is it changed signs. Okay, so this is always going to have a 3 over 2 in it. We can make the 3 over 2 positive, but it will never become 2/3. Okay, but I'm really happy that someone mentioned that because I see that all the time. It's a really common trap. Okay, what would we have to flip to make it positive? Yeah, the base. So we could make this 16 over 9 to the 3 over 2. Okay, and then now we're going to deal with the fact that it's fractional, so convert it to radical form. So the square root of 16 over 9 cubed, right? And the square root of 16 over 9 is 4 over 3. And that's, again, 64 over 27. Okay, now I will ask you guys to do this or to show how you would do this without the use of a calculator, just meaning like show your process. However, you can use a calculator to help you along the way. So for example, let's say you don't know what the square root of 16 over 9 is. You could use a calculator to get from here to the 4 over 3. That's totally fine. You could use a calculator to say what's 4 cubed and what's 3 cubed so that you get the 64 and the 27. You can do that. It's fine. You can also evaluate the original using a calculator and evaluate your answer using a calculator. You're going to get a long decimal. If those two match, though, then you're correct, right? So that's not necessarily going to help you show your process, but it will help you catch mistakes. Okay? All right, so I'm going to get you guys to do these two, and then I think I'll give back that pre-assessment in the last couple minutes. Okay?